Hi, a tough question was asked as a doubt on our Takshila study circle on Facebook. I think it's far tough than what Cat usually asks. However, we can possibly learn a few concepts and takeaways. There are a lot of takeaways from the question. So I thought I'll just do a video solution to it. So the question, you would have read it in the post here earlier, or it's there on the screen now. Please pause the video, try to understand the question, and once you give it a decent attempt, then continue with the video. I repeat, it's a tough one. So hopefully you would have given it a try. So we have a triangle and we know that it is an isosceles triangle with one angle being 120. Since it's isosceles, two angles have to be equal. The two equal angles cannot be 120, right? It's an obtuse angle. So obviously the other two angles, which will be 30 and 30 in this case. So these are concepts that you need to be very fast with. If I am going to struggle here, how this is 30, 30, then this question is not, you should not be attempting this question here. Further, it also says the question is inscribed in a circle with radius 2. So this is one big takeaway from this question, even if you would not have got the complete question. Circle of radius 2, I am inscribing an obtuse angle triangle. And an obtuse angle triangle will be inscribed in a minor segment. Minor means smaller part of the circle. So if I say this is the vertex of 120 degrees, so if I draw the 120 degrees, this is 120. This is the triangle, the others are 30, 30. What you should have known here immediately from your practice is, let's name the triangle ABC so that I can communicate faster. OA, OB and OC all are the radii of the circle and hence all will be 2. Look now how fast the thought goes. OAB and OCB, the right and the left, will be congruent triangles. OA is equal to OC, AB is equal to BC. Why? It's an isosceles triangle. OB is common. And since they are congruent triangles, the angles are also going to be equal. So the 120 degree gets bisected. Right? Oh, so I have a 60, 30. Obviously, the third angle has to be 90. So I get a 30, 60, 90. Yet again another thought. In triangle OBC, it's an isosceles. OB is 2, OC is 2, OB is also 2. Both are radii. Isosceles triangle with one angle 60 means an equilateral triangle. Oh, so all angles are 60, right? So these are thoughts that should come very fast in your mind. So hence we get the side BC is also 2. So all these four non-overlapping triangles are 30, 60, 90 triangles with hypotenuse being 2, side opposite 30 will be 1, side opposite 60 will be root 3. This is what I meant by, this is how I would judge how good is your geometry, right? Till now the toughness of the question hasn't come in. Therefore I said there's learning value in every question, even though it may not be asked in CAT as such, right? But these all thoughts should have been just immediately one after the other. And all come down just from these two words, 120, 30, 30 triangle inscribed in a circle. Now for the question and toughness of it. It says this triangle is rotated 90 degrees. Right? So this area, the question is about area, hence I am shading it. This is rotated 90 degrees. What is the area covered by the entire triangle from start to end? There's a little bit of ambiguity, so I'm just clearing it up. Once when we rotate this, we are rotating it about the center. So I'm saying ABC will always remain an inscribed triangle in the circle. Fine. And it's a complete area that is going to be covered, right? So every part, whichever part of the circle where the triangle is going to move, all that has to be counted as the area covered, right? So this point C is going to, let's say that it is moved anti-clockwise. The point B is going to be moved these. So C will move here and this area will start getting covered. A will move down, the area will get covered, right? This area, the moment B moves here, so I'm saying the second triangle would be like this somewhere here, right? So I'm saying this all area gets covered here, right? This area gets covered. But it's going to be tough to explain this here. That's the reason I'm doing this video session, right? We need some animation. So let's quickly move to an animated understanding of how the triangle goes. It will still challenge your understanding what is going, how the shape is going to be, right? So I'll show you the animation. Again, take a pause after that. Think again and try the question on your own. Now you should get it. If not, then I'll explain it in a moment. So let's have a look at the rotation of the triangle. The triangle has been shaded over here so that you can see the area that it covers. When I say 3, 2, 1, the triangle will start rotating anti-clockwise. Watch carefully. 3, 2, 1. Right? I'll just repeat it once more if you have not been able to figure it out. Though remember, you would have an idea and it's not very clear. You'll still not be able to see the area clearly, but let's have a watch once again. 3, 2, 1. The difficulty is identifying the entire area that is covered. While we can understand it is a complete circle around the circumference, but towards the center what area is going to be covered is difficult. For that we need to look at just the longer side of the triangle. So now on your screen you can only see the longer side of the triangle. Let's say this gets rotated and see the what locus is formed by the center of this line. So the line starts rotating and here it is moving anti-clockwise. We'll wait for it to complete its journey. It will move a full 90 degrees, that is, it will at the end it will become vertical, and here it becomes vertical. So if you look at the path that the center of the line has covered, it will be a complete circular segment, a circular locus. Since we are moving in steps, it was coming in as breaks, but then others it is going to be a full circle. Now having seen how the area is covered towards the center, we can move on to find the required area. So hopefully the animation must have helped you understand what sort of area the triangle is going to cover. So this is your initial position of the triangle. We have already seen that if I join OC or whatever, the radius is 2, this angle is going to be 60. We saw OBC is an equilateral triangle, right? And the end position B will move 90 degrees anti-clockwise. This is 2, each one is 1, 1, so at midpoint of the 2, this is your triangle longer side, this is your final position of the triangle. This picture is going to get a little messy, but however we just need an area, right? So do not worry. So how I am going to find area here in a faster way is, I am going to consider the complete sector. So OA and this would be A dash is also going to be an equilateral triangle. Angle is 60, this is 90. So I am looking at this complete sector of a circle, and this complete sector of a circle has a central angle of 60, 60, 120 and 90, 210. So the area of the entire sector is going to be 210 out of 360 degrees into pi r square. Right? Hope you get that. So this is going to be 7 3s are, 3 7s are, 3 12s are. So 2 square is a 4, so this will cancel out. So I will be having 7 by 3 pi is the complete sector. So I am just shading out the complete sector. So this whole sector I have found out. Now is the triangle going to take care of the whole sector? Not really. Like, so I know that the triangle is not going to be covering this area. And similarly, the triangle is not going to be covering this area either. So these are what sort of triangles? These are 30, 60, 90 triangles with perpendicular sides being 1 and root 3. So the area that is not going to be covered, what do I need to subtract? Half of root 3 into 1, and this will also be root 3, this will be 1, half of root 3 into 1. So I need to subtract a root 3, which is not covered, right? Further, the animation showed you how this line is going to become this line. That time it is going to make an arc over here, a circle. So this area is also not covered. And what sort of area is this here in between? This is nothing but quarter of a circle. So I also need to subtract quarter of a circle. And what is the radius of this? This is just 1. So pi r square, which is nothing but pi by 3. Okay, so pi is here, 7 by 3 minus 1 by 4. So that is going to be 7 by 3 minus 1 by 4 pi minus root 3. LCM is going to be 12, 28, 28 minus 3, 25. This is the answer to this tough question, right? I'm not too worried, I'm not too particular about whether you got this later or whether you got the answer or no. But look at how smooth you can go by being bold enough to take a sector which has a much larger central angle and then eliminating the areas which the triangle is not going to cover. A tough question at that. I cannot convince you what shape the triangle is going to cover. So but then however, if you are the ones who are going to, if you are aiming at 90-95 percentile or so on, this question need not be done. I'll be very clear about it. Even a 99 percentile, this question is not going to be necessary. It's not something that I would try in an exam. However, now we are not sitting for an exam. So I learned quite a lot of fundas. I learned 30, 60, 90. I learned isosceles triangle inscribed in a triangle. I learned a big funda when a line moves about a center, it is going to form a circle, a part of a circle. Yeah, when it's going to cover, if I talk of area being covered, right? So hope you enjoyed it. Thank you.